All right, so we are going to talk about the systems of linear equations in two variables. These are the straight lines that have a solution of an ordered pair that satisfy both equations in the system. So our first example we are looking at a system of x plus 2y equal to 2 and x minus 2y equals 6. So that's our system of equation. And we are going to determine if an ordered pair is a solution. So determine if each ordered pair is a solution. So the first ordered pair we're looking at is 4, -1. And what we're going to do is see if this is a solution for the system by plugging it in. So for the first equation, we have x plus 2y equal to 2. So I'm going to plug in my x and my y. So this is my x value, this is my y. So 4 plus 2 times -1 equals 2. So 4, 2 times -1 will get us -2. And 4 minus 2 is 2. 2 equals 2. It worked for the first one. All right, our second equation is x minus 2y equals 6. So we're going to do the same thing, 4 and -1. So 4 minus 2 times -1 equals 6. So 4, -2 times -1 is +2. 4 plus 2 is 6. 6 equals 6. It works for both equations. So because it's true for both, it is a solution for the system. All right, let's go try another ordered pair. So we have the point of -4, 3. And we need a new pen. So -4, 3. And again, this will be our x, and this will be our y. We're going to use the same equations that we did before. So we have x plus 2y equals 2. So -4 plus 2 times 3 equals 2. -4, 2 times 3 is 6. -4 plus 6 is 2. 2 equals 2. It works for that one. All right, let's try the x minus 2y equals 6. X is -4 minus 2 times our y value of 3. Gets us -4. -2 times 3 is -6. Well, -4 minus 6 is -10 equals 6. Well, that's a false statement. It's not true. So because one is false, it's not a solution for the system. It has to be true for both, like it was here. If it's only true for one, it's not a solution for that system. Now, the other thing we could have done is we could have graphed these two lines. And if we did, we have a graph right here, and made a t-chart, plotted some points, we would see that the two lines intersect at the point of 4, -1, which is the point that actually worked when we plugged it in. So there's different ways that we can solve systems. We can also solve them by substitution, which we're going to do next. All right, so let's look at example 2. And we have 5x minus 4y equals 9, and x minus 2y equals -3. Now we are going to solve by substitution. So to solve by substitution, what that means is we're going to solve for one of the variables, and in this case, the second equation, solving for x would be the easiest. Get x by itself, and then whatever x equals, we will sub into another part. So we're going to look at the first thing we're going to do is we've already discussed we're going to solve for x. So we have x minus 2y equals negative 3. So I'm going to do the opposite operation and move the 2y over and get x equal to 2y minus 3. Now what we're going to do is our second part will be to sub or substitute x equals 2y minus 3, and we're going to plug that into the very first equation. Because we are using this one, we have to use the first one. So 5x is now 2y minus 3 minus 4y equals 9. Now we'll distribute. 5 times 2y is 10y. 5 times negative 3 is negative 15. Minus 4y equals 9. Combine like terms. 10y minus 4y will get us 6y. Minus 15 equals 9. We'll add the 15 to both sides and get 6y equal to 24. Divide both sides by 6 and y equals 4. Now our third step will be to sub in or substitute in y equals 4. So I'm going to go to this one because it's a simpler one. We're going to find out what our x is. So x minus 2 times 4 equals negative 3. Well, negative 2 times 4 is negative 8 equals negative 3. We'll add the 8 over to the other side and get x equal to 5. Now on these systems of equations, typically the answer is an ordered pair. So our final answer will be to write it as x comma y, and in this case that's going to be 5 comma 4. This is your final answer. Typically they're going to be in an ordered pair. All right, let's go look at another example. In this case, we are going to solve by addition. And again, there's some steps on all of these, if you're in my class, on the handout, that you can look to see what the steps are. But we're going to talk about them as we work these examples out anyway. All right, so this will be example 3, and we're going to solve by addition. That means we're going to do some adding. Now this first example, or this example of addition, is going to be a pretty simple example because we want to just get the idea of how this works. We will do some more complicated ones in a minute. So as we look at this and we want to solve by addition, just like on the previous example where we solved by substitution, we want to get rid of one of the variables so we can solve for another variable. Well, we have 3x and we have negative 3x. Well, if I add those, they will cancel out because it'll be 3x minus 3x is 0x. So I don't have to do anything to these equations. I can just add them together. The x's will cancel. Negative 4y plus 2y will get me negative 2y, and 11 minus 7 will get us 4. Divide by negative 2, and we get y is equal to negative 2. Now we will sub y equals negative 2 into one of the equations. It doesn't matter which one you pick. I'm going to pick the top one because it has a positive x value, but you could also pick the second one. It doesn't matter. So 3x minus 4 times negative 2 for the y equals 11. Negative 4 times negative 2 will get us positive 8. Subtract the 8 from both sides, we get 3x equal to 3. Divide by 3, and x equals to 1. And again, our final answer will be an ordered pair of x, comma, y. Or in this case, 1, comma, negative 2. So this one was pretty straightforward because we didn't have to change anything. We could just add those two equations together. Let's go look at example 4. We are again going to use addition, but this one will not be quite as simple. So we have 3x plus 2y equals 48, and 9x minus 8y equal to negative 24. So I have to choose which variable I want to eliminate when I add. One of the variables has to be a positive, one has to be, whichever variable you choose, one of the terms will have to be positive, one will have to be negative, and they have to be the same numbers, just like on here we had 3 and negative 3. So I can either choose to cancel out the x's, or I can choose to cancel out the y's. I'm going to choose the y's because I already have a positive and a negative. So to get them to be the same value, I'm going to multiply the first equation by 4, because then I'll have positive 8y, and here I have negative 8y. So on the top, I'm going to multiply by 4. That should be by, sorry, my pen, I messed up there. And this one will be no change. And I'm doing this just so that as you're watching, you can see what did she just do? Multiply by 4, no change. So I'm going to multiply each part of this equation by 4. So 3x times 4 will get us 12x. 2y times 4 gets us 8y. And 48 times 4 is 192. This one is no change, so I'm just going to bring it on over just as it is. So 12x plus 9x will get us 21x. The y's will cancel and be equal to 168. Divide both sides by 21, and x will be equal to 8. Now, what I can do is sub x equal to 8 into one of the two equations. Again, it doesn't matter which one you choose. I'm going to choose this one because it has smaller coefficients on it, so it'll make the math a little bit easier than doing the second equation. So 3 times my 8 for my x plus 2y equals 48. So 3 times 8 will get us 24 plus 2y equals 48. Let's move the 24 over to the other side by opposite operation of subtraction. And we get 2y equal to 24. Divide by 2 and y equals 12. So again, our final answer will be in an ordered pair. Okay. All right, so the next thing that we're going to do is still do an addition, but we are going to solve something that's a little bit different looking, and sometimes we might end up with some like funky answers. They're not always straightforward. So for example 5, we have a system of 2x minus 7y equals negative 17, and 3x plus 5y equals 17. So we have to figure out what are we going to do. On this one, it doesn't cancel quite as easy like we did last time. We can't just multiply one of our terms by something to get to because they're not multiples of each other. So we're going to have to do something to both. I'm going to choose that we are going to go ahead and cancel the x's, and you could choose to go with the y's, but we're going to go with the x's on this one. So on the first one, I'm going to need to multiply by 3, and the bottom one I'll multiply by 2, but one of them has to be multiplied by a negative. So I'm going to do the top one as a negative because that way the terms will become positive because these are already positive. So I'm going to do by -3. And this one we will multiply just by +2. All right, so 2x times -3 will get us -6x. -7y times -3 will get us +21y. And -17 times -3 will get us 51. 3x times 2 will get us 6x. 5y times 2 will get us 10y. And 17 times 2 will get us 34. So we're still going to add them together. The x's will cancel. We end up with 31y equals 285. Divide by 31, and y equals 85 over 31. That is not a pretty answer. So I don't really want to plug this back into any of the equations because it's going to be a messy fraction. So what you can do if this happens is go ahead and solve for the x value by canceling out the y's just like we did up here. So you have options that you can do. All right, so I'm going to rewrite the system. And from here, I can decide what I'm going to change here. So because I want to do cancel out the y's this time so I can solve for x, I'm going to multiply the top one by 5 and the bottom one by 7. I don't have to worry about the negative because I already have a negative and I already have a positive. So this one would be multiplied by 5. And this one will be multiplied by 7. All right, so 2x times 5 will get us 10x. -7y times 5 will get us -35y. And -17 times 5 will get us -85. 3x times 7 will get us 21x. 5y times 7 will get us +35y, and 17 times 7 will get us 119. So 10 plus 21 will get us 31x. Our y's will cancel, and -85 plus 119 will get us 34. Divide both sides by 31, and x will equal 34 over 31. So, again, our ordered pair will be the x value and then the y value. So sometimes we might find that the answer may not be always like a pretty answer, but we can still solve the equation. The next thing we want to look at is sometimes our answers won't be just an ordered pair. We might get no solution or infinitely many solutions. So if we get exactly one ordered pair, those are two lines that intersect. That's like example 1 that we did. We can get no solution. That's going to be two parallel lines because they don't intersect at all. They're the exact same, or they're not the same line, but they're two lines that will just keep on going and never intersect. And then infinitely many solutions means it's the two identical lines. It's the same line. It just might be a multiple of the other one. All right, so let's go look at our next problem. We are on example 6. And our system is 4x plus 6y equal to 12, and 6x plus 9y equals to 12. So we need to pick a variable to cancel. Again, it doesn't matter which one. I'm going to go ahead and cancel the x. But I don't have to multiply the top by 6 and then multiply this part by a 4. I want to find the least common multiple. So what is the least common multiple between 4 and 6? Well, that's going to be 12, because that keeps your number smaller than going up to 24. I mean, you could do that, but if you can see a lower number, it makes the math easier. So if I want to get to 12 on both, one's got to be negative, one's going to be positive. 3 times 4 will get me to 12. So up here, I'm going to multiply by 3. And on this one, I only have to multiply by 2, but I'm going to do a negative 2 so I can have the opposite sign. So multiply by negative 2. All right, so 4x times 3 will get us 12x. 6y times 3 will get us 18y. And 12 times 3 will get us 36. 6x times negative 2 will get us negative 12x. 9y times negative 2 is negative 18y. And 12 times negative 2 is negative 24. Well, our x's cancel. Oh, and our y's are going to cancel. We end up with 0 equals 12. But that's not true. 0 equals 12 is not a true statement. This means we have no solution. These are two parallel lines. They never intersect because that's not a true statement. 0 can never be equal to 12. There's no variables left, so it won't be true. All right, let's go look at example 7. We have negative 3x plus y equals negative 2. And we have 15x minus 5y equals 10. So this time, I'm going to go ahead and cancel y. I have a single y and I have a negative 5y. So that means I can just multiply by 5 on the top. And I'll have positive 5y, negative 5y, so they will cancel. So on the top, I will multiply by 5. And on the bottom, there will be no change. All right, so this will get me negative 15x, positive 5y, equal to negative 10 when I multiply by 5. The bottom will not change, so I'm just going to bring it on over. Oh, my x's cancel again, so do the y's. So I have 0 on this side, and negative 10 plus 10 will get me 0. Well, that's a true statement. 0 does equal 0. Because it's a true statement, this tells us we will have infinitely many solutions. And when you have infinitely many solutions, typically the answer will be written as xy such that, that's what that line means, such that negative 3x plus y equals negative 2. You just pick an equation. Or you could write your xy point such that 15x minus 5y equals 10. So you can do either answer. You just pick one of the equations. Either one will be a true statement. And that just means, okay, we're going to pick any x to get, and it'll work. Okay? It'll work. Because they're just infinitely many solutions, which means it is the same line. And if you look at it, this is a multiple of negative 5, right? Negative 5 times negative 3 will get you 15. Negative 5 times 1y will get you negative 5y. And negative 5 times negative 2 will get you 10. So they're just multiples of each other. All right, let's go on to example 8. So on example 8, we are working some word problems because this is a business math class. So we're going to have to do a little bit more work on this. So a hotel has 200 rooms. Those with kitchen facilities rent for $100 a night, and those without kitchen facilities rent for $80 a night. One night when the hotel was completely occupied, revenues were $17,000. How many of each type of room does the hotel have? All right, so for these, you need to understand you're going to have, because these are kitchen, this will be kitchen plus no kitchen equal the total. All right, so you can use any variables. Typically, my students prefer x and y because those are the ones that are more common. So for the rooms, we're going to have x plus y, and they said they have a total of 200 rooms in the problem. So kitchen plus no kitchen equals the total of the rooms. Now we're going to look at cost. The cost of the kitchen room is $100. The cost of the no kitchen room is $80. And the total revenue, because we've got to have it equal a total, the total revenue was $17,000. So this is our system of equation. Now what we need to do is do some addition to cancel things out. So what I want to do is choose to cancel out either the x or the y. I usually will cancel out the y because there's less of them versus the x's. Even though this is the cost part, when you're adding them together, then you don't end up with a bunch of negative values. So to cancel the y, I'm going to multiply the top equation by negative 80, and then on the bottom one, I'm going to have no change. And just to clarify, like if you're in my class and you take an exam, you don't have to draw these arrows out. I do it because it helps us move into matrices a little bit, and it you understand what I'm doing. If I just do a bunch of parentheses, sometimes it's hard to follow. Where did that come from? All right, so this will get us negative 80x minus 80y equals negative 16,000 when we multiply through. And then we'll bring this straight over. 100x plus 80y equals 17,000. All right, 100x minus 80x will leave us with 20x. The y's will cancel, and this will leave us with 1,000 when we subtract the totals at the end. Divide by 20, and x will be equal to 50. So we have our x value. Now we need to go find the y. So we are going to sub x equals 50. We're going to use our first equation because that'll make it easier. So we have 50 plus y equals 200. Subtract the 50 from both sides, and we get y is equal to 150. So typically I put these in ordered pairs, but people may not understand what your x and your y are. So what I'm going to say is that for the kitchen, it will be 50 rooms because that was what we chose for x. And for the no kitchen, it will be 150 rooms. Because if I just put x and y, it may not be clear which one is which. All right, now we're going to go look at another example, and it'll be another business example because we need to understand how to apply everything that we are doing. All right. A theater sells adult tickets for $18 and children's tickets for $9. A total of 517 tickets were sold, totaling 6,219. How many of each type of ticket were sold? So it's basically the same thing like this, except we're doing tickets. All righty, so for example 9, we have adult plus children equals totals. So again, with this, we are going to have our tickets. Instead of rooms, we'll have tickets, and we'll have cost. So tickets and cost. So the tickets we're going to do is x plus y equal to, in our problem it said we had a total of 517 tickets. The cost of the adult tickets were $18. The cost of the children tickets were $9. And they had a total revenue of $6,219. So, again, we need to, this becomes our system, and we need to cancel out one of our variables. So I'm going to multiply the top one by -9. And the bottom one will be no change. So this will get us -9x minus 9y equals -4,653. And then this will be no change. 18x plus 9y equals 6219. That'll leave us with 9x equal to 1,566. Divide by 9, and x equals 174. So now that we have how many X tickets, which were the adult tickets sold, we got to go find out how many children tickets. So we're going to sub our X equals 174. So we'll get 174 plus Y equals 517. Subtract the 174, and we get Y is equal to 343. So again, because it's adult tickets versus children tickets, oh, and I left the L out of children, we will write that the same way again. And we're going to go just a little bit opposite. We'll go 174 adult tickets and 343 children tickets. So instead of saying it equals or whatever like we did on the previous problem, you can just say it's that many. All right, so now we're going to go do some more business type problems. We have a few problems that are left, and hopefully, because we're doing the same things over and over, it's starting to make better sense to you. Number 10, but we're going to recall a few things. Remember that C of x is your cost function, R of x is revenue, P of x is profit, and your break-even point is the number of items needed for the company to make exactly $0 in profit. That means your cost is equal to your revenue. You don't make anything, that's where you break even. When you bring in more revenue than your cost, that's when you make a profit. If you have more cost than revenue, that's when you don't make a profit and lose money. But the break-even point is when they're both exactly the same. All right, so example 10, we have a mower manufacturer has fixed costs of $48,000 per day and variable cost of $1,400 per unit produced. They are sold for $1,800 each. So the cost function is going to be our fixed costs plus our variable costs per item that we make. And the revenue cost will be the $1,800 that we sell them for times however many we sell. So how many units must be manufactured and sold each day for the company to break even? All right. So this will be example 10. So we have, we want to do the break even because that's what it says. How many do we have to do to break even? So we're going to set our C of x equal to our R of x. That's the break even. Let me write that off to the side. The break even, when the cost function equals the revenue function. All right, so our cost function was 48,000 plus 1,400x, and our revenue was 1,800x. Those were given to us in the problem, so all we got to do is solve. We'll move our x's to one side, and we are left with 48,000 equals 400x, and then we'll divide both sides by 400. And that'll get us 120 equal to our x. So we need to sell 120 mowers to break even. All right. And then let's go look at number 11. A company sells DVDs for $19.95. The monthly fixed costs are $24,000 and the variable costs are $7.95. And that is 7.95. Well, I wrote that. I I kind of made the decimal go away. I have a typo on there. Per DVD. So we're going to find the cost and revenue equations and then how many DVDs must be sold each month for the company to break even. So this will be example 11. And remember, our C of x is equal to the fixed plus the variable. And that's as far as our cost goes. So C of x, our fixed costs were $24,000 and our variable cost were $7.95 each. So 7.95x. And then we need to find our revenue function. The revenue function is what we sold it for times however many we sold. So we're selling the DVDs for $19.95 times the number that we sell of X. So that's part A. For part B, we're going to do the break even. And break even again is the cost function equal to the revenue function. So cost function, 24,000 plus 7.95x equal to the revenue function of 1995x. And it doesn't matter if you put the revenue on one side and the cost on the other, just so you know. You can put them as long as you have them set to each other. So we'll subtract out the 795x. And we get 24,000 equal to 12. And it'll be 12 even because the 95s will cancel. So 12 x. Divide both sides by 12. And we end up with 2,000 equal to x. So what that means is to break even, we have to sell 2,000 DVDs.